In this video, we're just going to look at a couple of things that we can do with a parametric curve and the derivatives. So the first thing, it says find the equation of the tangent line when t is equal to 2. Well, for every tangent line, of course, we need two things. I'm just going to put my first dot right here. We need a point and we need a slope. We have neither right now. Of course, the point we would get by plugging t equals 2 in. So 2 squared plus 2. So I know the x value is 6. Plug 2 in to the y value. So 4 minus 6 is negative 2. Plus 5 is 3. So there is my point. Now the slope, I'm going to need the derivative. So let me just remind you, we're going to do dy dt divided by dx dt, and that will give us dy dx. So the derivative of y with respect to t would be 2t minus 3. The derivative of x with respect to t would be 2t plus 1. And we're going to evaluate this at t equals 2 to find what the slope is when t is 2. So 4 minus 3 is 1. 4 plus 1 is 5. So our slope is 1/5. So our tangent line is 1/5 x minus 6 plus 3. There's the equation of the tangent line when t is equal to 2. Now you see the next question says find the equation of the tangent line at the point 2, 3. So this is a little nicer. It starts off with the fact we know the point. The problem is, of course, as we go to evaluate the derivative is in terms of t, and we only know the points. Well, it's easy enough to solve. You know, if I know that x is 2, I could simply say, well, what would t have to be to give me 2 right here? So I could say, you know, t squared plus t has to be 2. So you maybe could, you know, t squared plus t minus 2 equals 0. So you've got t plus 2 and t minus 1 equals 0. So negative 2 and 1 are my t values. Well, I go back up here, and if I plug in 1, let's start with that. We got 1 minus 3 is negative 2, plus 5 is 3. There it is. If you plug in negative 2, 4 minus negative 6 is 10, plus 5 is 15. So only 1 works. So t is 1 in this example. You need to check that. Of course, it needs to be a t value that works in both equations. A lot of times it will. You'll solve and you only have one t value to begin with. But in this case, we had two t values that would work for the x coordinate, but only one of those would work for the y coordinate. So we go up here, we say, all right, let's plug 1 in to find the slope. You know, now we're evaluating at t equals 1. So 2 minus 3 is negative 1. 2 plus 1 is 3. So it's negative 1/3 is our slope. So y equals negative 1/3 x minus the x coordinate plus the y coordinate. There's our tangent line. Okay. Next, it says find the points on the slope where we'd have a horizontal tangent. Well, a horizontal tangent occurs when the derivative, let me just make this note, is 0. That's going to occur when the numerator is 0. So we have to figure out where 2t minus 3 is 0. Of course, add 3 divided by 2. T has to be 3/2. Now, it did ask us for the actual point, not the t value. So to get the point, of course, we plug 3/2 back in here. So 3/2 squared is 9/4. 9/4 plus 3/2 or 6/4 would be 15/4. And the other value, in the interest of time, I just plugged into my calculator. We get 11/4. So that is the point. The points where we'd have a vertical tangent, well, a vertical tangent would occur when the denominator is 0 because the derivative would be undefined. So subtract 1, divide by 2, we'd be talking about t is negative 1/2. So the point, we'd plug negative 1/2 in, and we get an answer of negative 1/4 in the x and 27/4 in the y.